Hi students, let's look at this question here, which is on binomial distribution. I believe this is taken from the year 2021, paper 2, question 11 of the H2 Math paper. So a company manufactures a wide variety of components for use in domestic appliances. The company introduces a new type of light fitting for refrigerators. Each day, a supervisor selects a sample of 100 of the lights and fittings for testing. How should the light fittings be selected? Give a reason for this method of selection. Okay, so essentially it should be selected in a random manner so that each light, the selection, each light fitting would have an equal chance of being selected and they're independent of one another. This will just ensure that the sample is unbiased. Okay, so that's really important. Unbiased sample will ensure that it represents the population, okay, of a light fittings, okay, of the generally the entire thing which is manufactured by the company. So I'm going to just write it down and give the reason. So let's look at part 2. The supervisor record the number of 40 light fittings found on each day of the 150 working days. Now take note, every day he would select 100, right? The sample of 100 light every day. So essentially for number of 40, like so 0 for 4 days. Okay, so it's like 0 out of 100 and so on, right? So you have 150 days in total. Asks you to find the probability of a light fitting is 40. So this is the first one. You just need to count the total number of lights which are 40 over the total sample, right, size. Here's what's going on. So what we do is we just add up everything. So we have number of 40 days, which is 0 times 4. The number of 4 being one light fitting 40, you have 19 days. So it's 19 times 1. Then you just add everything up because 38 days you have got 2 41s and 41 days you got 3 and so on. So just add all this up. The total number of light fittings that is being examined every day, you examine 100 of them, so you have 150 days in total. So this is how you calculate. So I'm going to explain everything, 4 times 22 and so on. There you go. Then you just add everything up. The answer will be 0.03. 0.03. Okay, that's it. So let's look at part 3. Assuming that the number of 40 fittings day found each day follows binomial distribution of B 100p. So find the expected number of days for which 340 fittings are found. Okay, so the condition for each day is whether there are 340 fittings or not. So this is the case. This is the condition here, the event that you want to occur. Right. So out of 150 days. So this is like a binomial nested within another binomial. So I'm going to write it down. So conceptually, this is what's going on. You let x be the number of 40 fitting days found in each day. Okay, 40 fittings found each day. So x will be the random variable where it's binomial. You have every day is 100, right? Then you have 0.03. So let y be the number of days which satisfy this condition, days which 340 fittings are found. What it means is that this is actually px equals to 3. Okay, this guy here is whether it's satisfied or not. So y, binomial, you have 150 days, right? You just want px equals to 3. That's it. So this is how you do this question here. So just key in px equals to 3. I'm not sure px equals to 3 is a PDF. Here, distribution, so you go to binomial, PDF, then we have got the trial is 100, right? Success rate is 3%, so 0.03. Then you let the x value be 3. Okay, then you press enter. This will be 0.22747. Alright, that's it. So the required probability, sorry, not the required probability, they want the expected number of days for which 340 fitting. So you want to find EY. EY would then just be 150 multiplied by 0.22747. Okay, that will be a grand total of 34.12, which is actually 34.1 days. Okay, that's it. So that's how you do part 3. Let's look at the subsequent part. So the subsequent part, the company also makes heating elements for electric ovens. A fixed number of randomly chosen heating elements are tested each day, and the number found to be faulty is denoted by X. State in context to assumptions needed X to be well modeled by a binomial distribution. I think the first thing is that each heating element being faulty or not is independent of the other one another, and also the probability of them being faulty is actually held constant. Okay, so these are the two assumptions needed for X to be well modeled by a binomial distribution. So subsequently now assume that X has this distribution, then we are told find the probability that on a random least chosen day the number of elements found to be faulty is between 1 and 4 inclusive. So this case here will just be P 1 inclusive of 1, not inclusive of 4. Remember, this is if you have problem visualizing this, always draw the number line. So you always start counting from 0. These are like model these are classes, right? So you want essentially this one goes up to 5 and so on. I'm not sure how it looks like, but you have to take P x inclusive of 4 minus of Px equals to 0. Okay, don't minus off 1. A lot of students make a mistake of putting this one is 0 because you want this class, this and this and this. So here to here is your P x at most 4. Here, this guy here is Px equals to 0. Okay, so key in calculator shouldn't be an issue. CDF. So trial is 80, 0.02, then put this as 4, 0.97764. Then you can also use CDF. If you're lazy, you can just copy CDF, then put 0 here. It works as well. Just minus this both. 0.77899. So let's look at part 3. Part 3 says that find a probability that in a random chosen 5-day working week, more than 3 elements are found to be faulty on at least 2 of the days. So essentially, this is the case that you want to satisfy. Every day, you're asking whether you have more than 3 elements being faulty or not. So out of 5 days. So let me just write this down for you. So this should be how you structure your thought process. So let be the number of working days which have more than 3 faulty elements. Okay, of which this means this is Px more than 3, right? So it also means that this is Px more than 3 is 1 minus Px at most 3. Just key in calculator first. So V will be binomial 5 Px more than 3. Okay? Every one day you're asking whether you satisfy this condition or not. So then from here, what we want is the at least 2 days out of 5. So required probability at least 2, PV at most 1. Here will be 0.05049. King wrongly, so 0.050500. Alright, so that's the answer. So the last one is find the number, the probability that in the randomly chosen 5-day work week, no more than 8 faulty elements are found in total. So if this is total, you just group all the what do you call it? One day is 80, right? So you just multiply by 5. Just group all of them together. Remember, you have 400 heating elements for 5 days, but the probability that you're looking at it remains the same. You don't need to multiply by 5 to the probability, only to the number of heating elements. Okay, so this is the distribution that you're looking at. So 5-day working week, just group all the total together. So in this case, we have T binomial 80 times 5, which is 400. Then every one being faulty is just 0.02. So the required probability is PT no more than 8 means at most 8. Okay, so PCDF. Okay, will give us 0.59255. There you go. 3SF. So that's how I do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.